All right, so today we're going to focus on nth roots and rational exponents. So we're going to have to recall some of our properties of exponents that we've seen earlier in this class as well as in an Algebra 1 class, and then see how that's going to relate to roots and how we can write exponents as rational exponents as roots and vice versa. Before we do that, though, we want to recall some vocabulary because you're going to hear me use these phrases quite a bit, and I want to make sure we understand. So when we have something like this, x to the y, we want to make sure we understand that this right here is the base, and this is the exponent. So again, you're going to hear me referring to base and exponent quite a bit when we're talking about our properties of exponents. All right, so let's do a few examples to make sure we recall our properties of exponents. Here we have a few examples, and we're just trying to simplify, which in this case means kind of combine things as much as we can. So I'm going to do two of these examples first, and then I want you to try a few on your own. So first we have k times k to the fourth. So here, this is what we would say we are multiplying our bases. So if the bases are the same, and in this case the bases are both k, if I'm multiplying the bases, then I add the exponents. Now also keep in mind that if I don't see an exponent written, I can think of that as to the first power. So this is the same as k to the 1 plus 4, or k to the fifth. So that's how I can simplify this. Over here, number 2, I'm going to think of this as 4 times 6 times u to the 5 plus 5 times v to the 1 plus 2. And so then my answer here is going to be 24 u to the 10th, v to the 3rd. All right, so I want you to pause the video. I want you to try to do 3, 4, 5, and 6 on your own or with a partner, and then unpause when you are ready to check those. Okay, so for number 3 here, we can see that we have 5, a to the 3rd, b to the 10th, c, quantity squared. So now this 2, this exponent of 2, because these are all multiplied, gets distributed to each term. And if we recall, our property of exponents tell us that if I have an exponent, so in this case 3, raised to another exponent, so in this case 2, I multiply those. As opposed to up here, if I'm multiplying the bases, then I add the exponent. Here I'm not multiplying any bases, I have an exponent raised to an exponent, so I multiply the exponents. So this becomes 5 squared times a to the 3 times 2 times b to the 10 times 2 times c squared. I simplify this a little bit. A to the 3 times 2 is a to the 6th, b to the 10 times 2 is b to the 20th, and c squared is still c squared. I can leave this as 5 squared, or I can change that to 25. For the purposes of this problem, it's more just practicing your properties of exponents, so whether you leave it as 5 squared or make it 25 does not matter. For number 4, we've got a lot going on here now. So we're multiplying bases, just like we did in problems number 1 and 2, but we also have exponents raised to exponents, just like we did in problem number 3. So the first thing I did was I actually simplified this middle grouping. So I made this 3 to the 4th, x to the 4th, y to the 8th, because it was 2 times 4, and then z to the 4th. Now I did what I did in problems 1 and 2, where I'm multiplying the bases. So this is 3 to the 1st, 3 to the 4th, 3 to the 1st, so it becomes 3 to the 1 plus 4 plus 1. I have x to the 3rd, x to the 4th, and x to the 1st, so x to the 3 plus 4 plus 1. I have y to the 1st, y to the 8th, and y to the 1st, so y to the 1 plus 8 plus 1. And I have z to the 4th and z to the 1st, so z to the 4 plus 1. And this simplifies to 3 to the 6th, x to the 8th, y to the 10th, and z to the 5th. Similar to the last problem, if you want to actually evaluate 3 to the 6th, that's fine. It doesn't matter for the purpose of this problem. 5 and 6. So now again, we have a lot going on. We also have some negatives showing up, and this is where we really need to understand what happens when we raise a negative to an exponent. So what I'm doing is I'm actually thinking of, in this case, when I have negative g squared h, I'm thinking of this as just a negative 1 times g squared times h. Here I have a negative 1 times 2 times g times j to the third, all raised to the third. And here I have a negative 1 times g times h times j, all raised to the fourth. So the first thing I did was I actually simplified the second, or this middle grouping, and the third, or the last grouping. So I distributed the exponent of 3. So I think of this as negative 1 to the third times 2 to the third times g to the third times j to the ninth, because I multiply the exponents. Here, this negative, I thought of that as negative 1 to the fourth, and then g to the fourth. Here, this h gets raised to the fourth, and this j also gets raised to the fourth. Now I multiply the bases, so now I can add the exponents. So here I have a negative 1 to the first, negative 1 to the third, and negative 1 to the fourth, so that becomes negative 1 to the 1 plus 3 plus 4. I get 2 to the third, g to the 2 plus 3 plus 4, h to the 1 plus 4, and j to the 9 plus 4. There's my 9, there's my 4. Simplify again. 1 plus 3 plus 4 is 8. So then negative 1 to the 8th is actually just 1. So now I'm going to ignore this term because I don't need to write 1, but I want to recognize that that became 1. It's also really important that I keep these parentheses here. Otherwise, if I type this into my calculator incorrectly, it will give me an answer of negative 1. This stays 2 to the third. This becomes g to the 9th, h to the 5th, and j to the 13th. So I can write my answer as 2 to the third, g to the 9th, h to the 5th, j to the 13th. Or if I want to evaluate 2 to the third, that's 8, and then g to the 9th, h to the 5th, j to the 13th. Last one. Again, here I'm going to actually deal with this negative and the quantity to the fourth. So I'm thinking of this as negative 1 to the fourth times y to the fourth. Negative 1 to the fourth is actually positive 1. So negative 1 to the fourth times y to the fourth is actually just y to the fourth. Now I multiply the bases. So I get 2x y to the fifth plus fourth. So that's 2x y to the ninth. Excellent. Moving on. So that was a good refresher of our properties of exponents. That's going to help us with some of the problems later on. And just remembering how exponents work is going to help us when we're solving some equations as well. So a big thing we're going to focus on today, though, is rational exponents and how we can convert from radicals to rational exponents and back and forth, and how we can evaluate those in our calculator as well. So first thing I want you to do is I want you to type these into your calculator. The big point of this is, 1, to see that we should get the same answer either way, and also 2, to make sure we understand how to type these into our calculator. So I'm going to go through this with you. First we have square root of 9, and then we have 9 to the 1/2. So on my calculator, I can do second square root of 9. I get 3. Excellent. And then I can do 9 raised to the 1/2. And I also get 3. Now, one thing I want to point out, it depends on how new or old your calculator is. It might format this really nicely like mine did here, or it might not. And so if it doesn't, these parentheses are really important. If it does format it nicely like mine did here, I actually didn't need the parentheses. However, just to be safe, I would always recommend you use them. That will avoid any mistakes. So I know this is 3. Here we're going to do the same thing. So I can do square root of 2, and I can do 2 to the 1/2. And we get the same thing. So we're going to round that to 1.414. Here I have the cube root of 8 and 8 to the 1/3. And so this is where it might start getting a little more complicated typing into our calculator. To do a cube root, if you hit math, and then notice the fourth choice down right here, has the little 3 and then the root. So I'm going to type 4, and then we want the cube root of 8. We get 2, and then we're also doing 8 to the 1/3, and we get 2 as well. For D, we're going to do the cube root of 3. So I'm going to do, math, fourth choice down, 3, I get 1.442, and then I'm also going to do 3 to the 1/3, and I get 1.442. Just to reiterate, if you are confused on why we're doing this, the point is to make sure we understand how to type each of these into our calculator. Here I have the fourth root of 16 and 16 to the 1/4. So how do I do a fourth root? Well, notice if I hit math again, the fourth choice down was cube root, but the fifth choice down, it just said x root. So that's what I'm going to use. So how I use that is if I want to do a fourth root, I'm going to type 4, then I'm going to hit math, and then I'm going to type 5 to go to this fifth choice, and it puts that as a little fourth root. And we were doing the fourth root of 16. So I type that in, and I get 2, and then we're also doing 16 to the 1/4. And I get 2. So I know this is 2, and then we'll do the fourth root of 12 and 12 to the 1/4. So I do 4, math, the fifth choice down, 12, 1.861, and then 12 to the 1/4. 1.861. Okay, so last emphasis is on making sure we understand how to type this into the calculator, and then also, hopefully we're recognizing, oh, this fourth root can also be written as a rational exponent. And remember, rational just means the ratio of two integers. If that's confusing, just think of it as a fraction, all right? So now let's formally talk about that. Well, if I have a to 1 over n, where n is the root, so think about here, the n was 2, so we call it a square root. Here the n was 3, so we call that a cube root. Here the n was 4, so we call that a fourth root. If I have a to the 1 over n is an nth root of a, where a is just a number, and m is a positive integer, then a to the m over n is a to the 1 over n to the mth power, which is the nth root of a to the m. If we put a negative in front of that, it does the exact same thing. It just creates a fraction out of the whole thing. This is something we've seen before. So just to show you an example of both of these. So here, if I have, let's say, x to the 5 over 3, I'm going to follow, so here's an example of this first part. This is the same as x to the 1/3 to the 5th, right? And we know that that's our property of exponents. If I have an exponent raised to an exponent, I can multiply them. 1/3 times 5 is 5/3. And then ultimately I can write this as a root. So x to the 1/3 is the cube root of x, and then this is to the 5th power. If I look at a similar example here, I'm going to say I have x to the negative 3 over 2. So I can write this as 1 over x to the 3 over 2. So that's what the negative does. The negative takes this whole thing, which is x to the negative 3 over 2, and it makes it a positive exponent, but in the denominator. Then this becomes 1 over x to the 1/2 to the 3rd, which is the same as 1 over the square root of x to the 3rd. Notice that when we have a square root, we don't write that here, right? If we just see this root, we know that that's an index of 2. Okay, that's the end of this video. Go on to the second video to continue with the notes.